Hello everyone, my name is Vince Hammond. I'm your host for this last and final session in Lisp programming for DraftSight. In this final session, we're going to cover specifically the dialog programming language, or the DCL language that we use to create interfaces for DraftSight in our Lisp routines. If you have not attended the previous videos or previous sessions, I would highly recommend you go back and watch those prior to this video, because a lot of what we're going to cover today is going to be based on the things we've learned leading up until this point. So those things, some of the things that you'll see in this video will be continuations of things that I've shown you in the previous videos. So to get started, let's talk about what we covered last time. In the last video, we covered block management and attributes, and I did cover how to do data extraction with those attributes, and then I also showed you an alternative to attributes, which was extended entity data, and how you can use that information to attach to either blocks or to objects within your drawing. One of the last things I covered in that video series was the file editing, opening and reading and writing to files. That's very important because I'm going to show you some methods that I think are better to use in terms of creating DCL files using some of that methodology. So definitely important to go back to that video if you have not watched that video yet. So for this particular session, I'm going to cover the dialog control language, and to be honest, I could probably spend 8 to 10 hours on that subject alone and still not cover it all. So this introduction video is just going to sort of go over some of the basics and give you enough information that you can create some very simple dialogues, and then also be able to launch those dialogues and then retrieve information from them. But definitely a subject that you could spend a lot of time on, or I could spend a lot of time on going over. After that, we're going to continue with a couple different commands and functions that I maybe either didn't cover before, or maybe I skipped over them, but I did have a couple other functions that I wanted to point out to you. And then I'm going to go through a handful of examples, just a couple examples that I have that I think are going to be very important. They might be very useful for you. And the final example that I have that we've had a lot of requests for is a command to publish the PDF. And that is a program that will take all your layout tabs in your drawing and create PDFs of those in an automated fashion. So I think it'll be a really good takeaway for you. It might be something that you can use on a daily basis. And then to wrap it up, we'll go over a couple different best practices. We'll talk a little bit about references, and then we'll close out the session. So to get started, let's talk about the dialog control language. It's very different from the Lisp language in that you'll notice that there are no parentheses in this file. We use these braces instead, and the semicolon is not a comment line inside of this DCL language. The other thing is there is no WYSIWYG editor that we can use to lay these buttons out. You basically have to build this through a textual means to build those buttons and the interface for the dialog. Now that can be a little bit cumbersome, and it can also be one of these things where the formatting can sometimes be difficult to work with. Just to let you know that sometimes the spacing doesn't always behave in the way you think it should. This language hasn't really had much updates in a couple decades, and so for those of you that are used to more of an interface where you can just drag and drop and place things in the drawing, unfortunately, or in the interface editor, unfortunately, we do not have that capability here today. So continuing on, let's talk about an example. So in this first example, this is a simple dialogue that I like to use over and over again. It's something just to ask yes and no. The reason I like it is because I prefer to pop up a dialog box on the screen where someone can just hit enter if I want the default to be yes or default to be no, instead of having to type Y or N at the keyboard during one of my programs. It's also nice because having that pop up in the middle of the screen is typically where people are focused as they're running through these programs. So to start out with, you'll notice that I'm going to create a file. We're going to call it yesno.dcl is the name of the file. So the format is basically the name of your dialog, a colon, and then the word dialog. And then we're going to define the different objects in this dialog box, and then we will have parameters for those objects, and then within those braces is where you're going to see the parameters with the name equals and then the value for those parameters. So what type of objects do we have? Well, we can create rows and columns, and in this case we can also do boxed rows or boxed columns. You'll notice that in that situation, like in this example here, I've got a row of buttons and then I've got a row of radio buttons with a label. So sometimes in this case it's a boxed row. So we can do that. We can add buttons. Radio buttons are like the old FM radio. If you push one in, the other two options go off. If I push on 2, 3 and 1 would be turned off. Only one button in a radio row can be active at a time. And then the other is we have toggles where we can turn these things on and off, a check mark. And then we can also do what's called an edit box or a piece of text. The edit box is something you're probably going to use quite a bit because oftentimes you're going to want to provide an interface and grab information. And so typically you'll see edit boxes being used quite a bit. Now we also have something called a pop-up list and a list box where we can create a list of options that are there in either a pull down or they call it a pop-up, and or you could display that list in what's called a list box. The final object type that we have is an image, and we're not going to be covering images, and actually we won't be going over these list boxes in this session, but definitely something you can do in terms of providing information for your interface. Images have to be a certain format, so it's a little bit more of a challenge to put those types of images together and display them in the interface, but certainly something that is possible. Now, when we look at the way the file's laid out, you'll see that we have a key or a label, and then once we define whatever that key or that label is, you'll see the semicolon that's used after that value. Also, within a dialog, when you define your dialog, you have to have some type of a close parameter. There's a number of options here. You can say OK only, or is cancel, or OK cancel, or is default true, or is cancel true. It has to have one of these in there. Now this is kind of an important thing because I catch myself doing this often where I'm creating a dialog box. If you forget to put one of these closed parameters inside of the dialog box, there's no way to turn the dialog box off, and so I've often gotten into a situation where I've actually had to delete or Control-Alt-Delete to give the to get to my task manager and shut down my CAD program just so I can go back in and redefine these dialog boxes. So something to keep in mind. Be very careful when you're doing this. Make sure you're not working on production drawings when you are working on these dialog boxes, because if you forget one of these closed parameters, you will not be able to get out of the interface that you've got displayed on the screen. Depending on the type of object you have other parameters that you can add to that definition. So for instance, if I have an edit box and I need to make sure it's a certain width or certain length so I can type enough information in there, I can define the width of that. If I have a list box, I can define its height. And also there's another parameter that I often use when I have larger list boxes that have a specific type of text in there that I want to line up properly. You can also turn on a toggle which is called fixed width font. What that does is it basically makes the font monospaced, so each character is the exact same width, and then also more bold. So sometimes I use this as a trigger in certain areas of a dialog box that I want to either be more bold or needs to line up with something else. So you might see examples of me using a fixed width font for the certain types of interfaces. So here's an example of a DCL file that represents our yes/no dialog box. And to go through this, I'd like to just do this a little bit more in detail. We'll do it one line at a time. So the very beginning is the name of the dialog. We're going to call it yes/no, a colon, and then the name dialog. And then we start the parameters for the overall dialog box. So you'll notice an open brace, and then in this case we're going to give it a label at the very top. We're going to make the default, if you hit the enter key, to be the yes, and so I'm putting that text here, calling a default enter equal yes. Then the next line will be, we're going to do what's called a boxed column. Now that probably don't need a box around that. I could have just called it a column, but you'll see I get that extra box around there. And then the first thing within that column is a piece of text. So in this case, the key for it is going to be a prompt, a yes/no prompt. So we can take a variable in our Lisp routine and we can feed it into that key. And then we can, here's another type of parameter, we can do an alignment. In this case, we're going to say alignment equals centered. Now, sometimes this works, sometimes it doesn't. You can align it left or right, but certainly in this case, it does work properly. And then we can also set a width. So we want this box to have some space in here. So if we put a sentence, or we have a longer request, you can show that in this interface. Then below that piece of text, I'm going to do a boxed row. So you see that box around there. And then I have two buttons. The first button I'm going to call, the key is going to be yes, no, yes. And the second one will be yes, no, no. And then I just provide the labels. And then here's my closer. My is default equals true. So that I've assigned that default to that button. So if someone just hits enter at the keyboard, it recognizes that if there's an enter, then this button it'll be as though this button was pressed. Then we close the boxed row, just like we do with the parentheses in Lisp, except we're using braces here. We close the boxed row, and then we close the boxed column, and then this final brace is to close the parameters for the overall dialog. So in some ways, we're lining up braces like we do parentheses, but again, in the DCL language, we do not use parentheses. Now I want to point out a couple different options here. I think you saw this dialog box come up earlier where I have a dialog where I'm displaying some information. I'm displaying the object layer, the layer color, and the object color, and I'm using text to do that. So in this case, it's a field that I don't want to have the user edit. I just want to show the current value, and so I'm going to use text. So if we look at the very beginning of this dialog definition, you'll see I'm calling it a DDCR dialog. I'm giving it a label, object color changer, and then in the first row I'm using a text and I'm giving it a label of object layer, and then the next piece of text is actually the key, which is the layer name, and then after that I'm going to do a piece of text that says layer color equals, and then I'm going to use a key for layer color. Now, something to keep in mind, when we use text objects, I can have either a label or a key, but I cannot have both of those parameters in a text object. So in this case, when you see this row that I'm defining, I'm actually defining text, key, it's the label, the key, the label, the key, and then I would continue going on with that in order to make this work. Now let's say I wanted that interface to be able to have where the user could type something in there to change it. Well, if I wanted to do that, I would use an edit box. And so here, pretty much it's the same interface. I'm going to say text, label, object layer, but instead of text here, I'm going to use an edit box for the key, and I'm going to call the key layer name, or this key would be layer color. So you notice how it is different where I have the edit box versus the text. Now, with an edit box, I could have actually put the label and the key in, as both of those parameters can be in the edit box. Just a little, little quirky thing about this DCL language, and that, if I'm just doing text, can't put the object, I can't add the label and the key, but if I'm doing an edit box, I can. So the other thing I wanted to just show you here is formatting. Now, if you download or you go up to the web and you find people that have written DCL files as an example, a lot of times you're going to see them in this format. You'll see the label, you'll see the row, the text, and then each of the parameters are listed one by one. Now, you could do it that way, but my personal preference here is there's no reason why you can't do this, and sometimes it's easier for me when you look at this. You'll notice how I can put all the parameters on one line within this text file, and in some ways this is much easier to read. So neither is wrong, but you'll notice that this tends to be harder to make sure that you're not missing a brace. Whereas if I look at this format here as I'm typing my code, you'll notice I know, for instance, I'm not missing any braces here, and that my semicolons are all lining up, and I've got the labels and the keys, and they're all typed correctly. Just a much easier method to use, but neither is wrong. It's just I'm showing you a preference that I like to use. Okay, so now that we have our dialog DCL file created, how do we launch that file, or how do we launch that interface inside of our Lisp routine? So now I'm switching back into Lisp mode, and the format that we're going to use is we're going to set a variable to the function called load dialog. So we're going to use load dialog, the name of our DCL file, and we're going to set this to what we call a DCL ID. Now the next step is to see if we can launch this dialog from this file. So again, I'm going to work from the way inside out here. So we're going to use a function called new dialog. Whatever the name, now in our case before it was a yes no, so we'd say yes no for this ID. If this does not launch, then just exit out. So it's more of an error check here, but we need to do this. We need to use the new dialog function, and then if this works properly and everything went okay, then we can continue on. So once we've loaded the dialog, we then have to set our values and the actions for the interface. If there's a value for set tile, if we have something, for instance, in the previous one we used a prompt, or like in the example I was just showing you, let's say we had a tile called layer name. Well, I could say set tile, whatever the key is, and then whatever the value is that I want to put into that key. So in this case, I can say set tile layer name is whatever our layer name is. So once we've defined, if we have tiles that have to be either turned on or off, sometimes like toggles, we could turn them on and off, or with edit boxes, we can put information in there, or with text, we can assign that key, that piece of text. Once we've done that, we then do something called action tile, which is if someone pushes the button or types into that edit box, what is the action that's going to happen after that activity, after that happens. So an example would be we do an action tile for maybe our key is DDCRU, we push this button, and what I'm going to do is within quotes here, you'll notice I can put my, what I'm going to do. First of all, I'm going to set a variable. In this case, I'm going to set the variable called function1. I'm going to set it to a value of 1, integer of 1. And then if that button is something that I want to finish the interface, I can actually put this done dialog command in there, and then it will exit out. So as an example, I might have 3 buttons. Each of those 3 buttons will close the dialog box, and so depending on which one the person or the user picks, I can set the function key to 1, 2, or 3, and then I can exit using this done dialog. Once we've defined all of our actions, then we can actually start the dialog or load it up. So the way we do that is we use a function called start dialog, and then we have to do an unload dialog, and which is this this ID that we have just defined. So these things are pretty common. This syntax that you have here, you can pretty much copy the load and the start, and then if you have parameters, put that in here, and you can define those things within your interface. All right, so why don't I show you how to load these up and how that works in DraftSight. So I'm going to quickly just jump over to DraftSight here, and then I'm going to show you, I've got the 2 files. I've got my yesno.dcl file, and I've also got my, here it is, my yesno Lisp routine, 2 separate files. And like I showed you before, I'm going to call the DCL file using the new dialog. I have a set tile, an action tile, and then we start the dialog, unload the dialog for this function that we've created called yes no. So let me just drag this over. So to do this inside of DraftSight, I simply say load yes no. Now that I'm doing it manually, we can actually set this in our startup so it would load all the time. And now we have a function called yes no. So if I say yes no, and then I give it the text that I want. For instance, I could say exit drawing. Maybe it's something we want to ask before we leave or quit. You'll notice here I get my dialog box. I've got exit drawing as my text, and if I hit enter, you'll notice it returns a yes. If I just run that again, and this time I actually physically pick on no, you'll notice it returns a no. So very simple interface, but now I can use the yes no function to ask any kind of question that's a yes no question and use that methodology to launch it. Now I do want to show you an alternative here, and this kind of goes into what we talked about last time in terms of creating files and writing files from Lisp. I have a different methodology that I like to use, which is instead of creating a DCL file that is separate, I like to use a Lisp routine. In my Lisp routine, I like to create the DCL file from the Lisp routine. Now, there's a couple of reasons why I prefer to do this, and I'll kind of go through those with you. And as you can see on the screen here, I've got an example of how this happens. But I'm going to just jump over to Notepad++ for a second and show you one of the reasons why I do this. For instance, I'm looking at the yes/no DCL file. Now, you'll notice that in Notepad++, because it doesn't have an actual filter for doing DCL files, it treats it like a Lisp file. So anytime it sees the first semicolon, everything after that semicolon is considered a comment, which is not true in a DCL file, but that's how it gets treated here. Also, if you notice that when I highlight any of these braces, they don't line up correctly because it thinks that this brace here, that is actually the close of this brace, is inside of a comment, so it ignores it. And so you'll notice that it just doesn't, while it color codes certain of the object types, it doesn't behave properly when it comes to semicolons and the braces. So as an example, if we look at my startup, when I create this as a single line, if I highlight this brace here for my dialog, the parameters, you'll see that it closes that properly, or it highlights this brace to that brace. So just something that it does if I use this methodology. And we'll go back to this and we'll kind of walk through it and show you what I'm doing here. But there's another reason I like to do this method, which is oftentimes if I have two separate files, I have to manage those two files, and I have to always send those two files instead of just a single Lisp routine. So in this case, if I use this method, I can have my Lisp routine create my DCL for me and then run it so that it's all nicely packaged up in one little file. So how do I do that? Well, the first thing I'm going to do here is I'm going to define a function called my yes/no DCL. I'm going to find the startup where the startup is, and then I'm going to strip out the path, and then I'm going to add yes/no to the path, and then we will basically open the yes/no file to write, and then I'm going to use the function called writeLine, and we talked about this in the last training session. I'm going to writeLine to that file the text that I want, and then the file is yes/no DCL. I'm going to write this string to there, and then when I'm done, I'm going to close that file. So there's a couple things here. Now there's some limitations. Whenever I use the writeLine command or function here within this program, I can only write about 2,000 or so characters to that per writeLine function. So if the DCL is really long, I basically break it into chunks and I use multiple writelines. So typically not a problem, but just something to keep in mind. Also, you'll notice that here, anything that is a string inside of the DCL has to be prefaced with a backslash. So I have a starting quote and an ending quote, but then all the quote marks that are inside just have to have this backslash quote mark. Now, you might think that's a little bit extra work, and some people may prefer to split these into two files, but for me, I like to put these all in one file because it's just easier to manage. The other thing that happens is if I jump back in here, you'll notice that if I highlight in Notepad++, you'll notice that it highlights that variable name, and I can see that it's also the variable name inside of my yes/no function. So, you know, just to sort of show you the difference here in this interface, anything after the semicolon is a comment. We're down here. You know, it's a personal preference thing. It might be easier for you to read it this way, knowing that the braces won't light up. But for me, when these DCLs get really long, it's more convenient for me to be able to understand where the braces are starting and where they're ending. But, you know, again, it's a personal preference. So let's talk a little bit about, as long as I'm in here, I do want to show you a couple things about Notepad++. If you go to Notepad++, under the style configurator, under settings, you can control all your colors that you've got set up. Now, for instance, for me, if you'll notice, the default color for is a foreground color is orange, comment lines are green, Numbers are red. And so you can control the colors. Now, these are my preferences. Some people may choose different colors. I like my strings to be orange. But also, you can create your own special commands or your own functions. And if you create your own function, it'll show up as a magenta color, which is one of the things I really like. So, Notepad++, very easy editor, especially when I start working with DCL files and Lisp routines that are loading DCLs. You'll notice the fact that I can pick on these open parentheses. I can show where they're closing. I can make sure that they match the highlighting. And then here's my yes/no function. And again, if I pick on this ID, I can see that the file here is the same. It's the same variable. So just a couple quick tips about Notepad++. Now, while I'm in here, you'll notice that the file I have open right now is my startup.lisp, and if we scroll up, you can see I had the other functions that we did earlier. They're all in here. And so typically I might put this, first I would define the function or the DCL first, and then once that's defined, then I define my function called yes/no. So by it being in my startup, this function is always available to me, and so I can now use this in other Lisp routines that I would load up later on. So let's talk about a couple different functions or commands that I didn't cover, or maybe I missed them before. The first one is, and you may have seen it, but there's a function called progn, P-R-O-G-N, and what that does is it combines lists or lists of functions together. So where would we use this? Here's a good example. Let's say I have an if statement where I want to check a variable to see if the variable is equal to the integer 1. So if this is true, and if it is true, I want to do a number of different things. I want to run set queues. I want to do some actions. I want to do other things. Well, if you remember with if statement, if the first thing is, if the item is true, it does the first thing. If not, it does the second thing. Well, what if that first thing has to have multiple functions? Well, we use a progn to be sort of the container to put multiple functions in. So I can, in this case, I could say, well, if the user val is 1, then go ahead and set queue this value to this +5, set an index to the index +1, and run my function, do a whole series of things. And then when I'm done, I can end the progn, which will close this, and then I can end the if. So progn is you'll see that in a lot of my programs. You may have seen it in a couple, and I know you'll see it in a couple more that I'm going to show you, but it's basically a container that holds multiple functions within one grouping. The other function I do want to show you is something called initdia. It's short for initialize dialog, and in some cases we have commands that require the dialog to be initialized for the command to work. So let me give you an example. There's a command called export PDF, and if we try to launch that from Lisp, if we try to create a Lisp routine to launch it, it actually won't launch properly. So if I say command and I say export PDF, even though I know this is it's a command inside of DraftSight, when I hit enter, it's basically going to give me an error, and that's because I cannot launch that without initializing a dialog box. So if I just repeat that, but instead of just doing the command before that, I say initdia, and I just type the same thing. Now when I launch it, I get my PDF export interface. So something to keep in mind, if you're trying to launch a command and it's not launching properly, if it has a dialog box natively associated to it, it may be that you have to initialize the dialog editor so that dialog will display properly. So just something to keep in mind, especially if you're seeing a general error or any kind of error where your command isn't working properly. So initdia is one of those functions. Now I think you may have picked up on this, but I did have in my last yes/no, I used a function called find file. And what find file does is it searches for whatever the file name is that you give it, and then it returns the full path and file name if it can locate that file name. And I use this a lot. The reason for that is I want to make sure I find that DCL, or I want to make sure I find the file before I continue moving on with my program. So in this case, I'm going to use an example where I say, again, from the inside out, I'm going to use the find file in my file. And if it's not that, if I don't find it, well, then give me an alert that says this file was not found. Now, if it does find the file, well, then I can say, run this progen and do all of these things, and then end the progen and the F. So a lot of times you'll see me using find file to make sure I locate whether it's a DCL file or if it's that file I created with an attribute extraction or anything. I want to validate that that file is there. And so by using find file, I can do that. So those are just a couple quick little examples of some functions that I may not have covered previously. So let's talk about a couple more examples. This one's a little bit wordy. You'll have it on the screen, and it'll be part of the startup that you'll be able to download. But I just wanted to show you that here's an example of something I use all the time. It's called remove left and right spaces. So if you recall in the previous video, we did an extract, or we extracted attributes out to a text file. Now, if you open up that text file and you read it back, remember, in order to do that with Lisp, we had to use a space delimited file, which means if I grab some data from that file, chances are I'm going to have a lot of empty spaces that I have to deal with. And so one of the functions I like to do is use something called rtrim, or it's my own function, to remove the left and right spaces. So if I were to use the function and I say open parenthesis rtrim, and then whatever the piece of text is that has spaces, it'll trim out the prefix and suffix spaces, but it'll leave alone any spaces in the middle of the text. So if you look at this function, I start it with an if statement. If that string has a value, then I'm going to run this first progen, which is while I can identify if the first character is either a character 32, which is a space, or a character 9, which is a tab, then just substring this, reduce it by, start at the second character. And notice it's a while loop. So it just runs through that, checking the first character to make sure it's a space or string. And then the rest of this is very similar. It just does that to the trailing edge of that. So if you get a chance later, you can sort of study it. But it's an example of another Lisp routine that does something with a string, and it might be a useful tool. Now, another one that I use very often is, I think you showed it before, a lot of times we want to ask yes and no. What if I always want to ask just for a piece of text, and instead of having it down on the command line, I'd rather have a dialog box that shows up. So in the same manner that we created the yes, no, in my startup, I can say I'm going to define the getString DCL, and here's the code for that. It's basically a dialog box that is defined with a piece of text over the top of an edit box. And so you notice here I got a boxed column with a text and an edit box. I write that out to my dd getString DCL file as the first function, and then the second function is my dd getString. And what it does is it basically looks to see if there's a default value that's already existing, then go ahead and set this dialog box with the default value. Otherwise, ask for the string and then set that to the value. So how does that work? So if I'm in DraftSight and I want to use that function, and let's say I put it into my startup so it's always available, I can say dd getString, and we'll use enter name as our parameter, and you'll notice there I've got my dialog box that just says enter name. So very simply, if I've put a value there, now that's the default value for the dialog box. So if I ever pop it up again, you'll notice it has my name as the default. So just simply a function that I would use for DraftSight to ask for strings, a simple dialog box, but I can use it over and over and over again. And if I know what, here I'm using dd string default as the default variable. So if that exists, maybe I can grab the login name and I can set that to dd string default. Or if I already know that I want to have a default value for something, I can use that as the default value, just setting that prior to asking with the dialog. So just another example of a Lisp routine. So the one we've gotten a lot of request for is a program to publish PDFs. And so I do want to show this. There's a couple different things we can do. Now here's the code that I wrote that will do a publish of all the tabs or the layout tabs that are in the current drawing. Now, some of this is a little bit more complicated, but I think what's good here is I can show you and give you this code so you don't have to figure out how to get the list of tabs and how to sort that information. This stuff is a little bit more complicated. You're probably not going to be doing this early on, but here's the code, and you can simply take this code and use it. So let me walk through how this works. The first section, the first command here is really just grabbing the layout names and putting them in the list. And then I'm going to set a variable called tab list to the list sorted. And then I'm going to set it again to the same list, but if model is in the list, I'm going to remove it. So, and it's going to convert it over to a list. So then once that tab list as a variable exists as a list, we do a for each statement that says for every name of every layout tab that's in here, go ahead and do this. And so we're going to create a PDF file, which is, we're going to give the name, we're going to take the name of the prefix of the drawing and the name of the drawing, and then we're going to add the tab name and as a hyphen layout tab.pdf, and then we're going to use the plot command to plot out in this sequence of events. Now this is very important. In order to get this to work properly, oftentimes you'll want to test the prompts as they go through the drawing to make sure that you're answering all the questions in the specific order. Why don't we jump over to DraftSight so I can show you what I mean here. For instance, I've got this other drawing, this pump drawing, and when I want to plot a PDF of this, if I just type in -plot, you'll notice that instead of getting the dialog interface, it's going to ask me on the command line all the options. And so the first question says, do you want to do the advanced print options? We'll say yes. Then the sheet name that we want, in this case we could say sheet 1. So we have to type it in there, notice. And it goes to that sheet, and then it says specify printer name. Now if we don't know, you can actually type the question mark here, it'll give you the list, but I know that it's going to be PDF. So I can do that. And then it asks for the paper size. I'm just going to accept the default here, but you'll notice at all these options you can type the question mark to get the exact text that you would need to put in there if you wanted to verify or validate that you're going to do exactly that paper size. And so specify paper size, I'm just going to hit enter. And then units, is it inches or millimeters? In this case, I'm going to say inches. Portrait or landscape, but you get the idea. Basically, you walk through all the steps answering those questions, and oftentimes I'll sit down and write those down on a piece of paper so that I know that I get the sequence of events down. I'm just going to cancel here and jump back to our dialog, our program. But you notice here, I'm actually going through and answering all those questions one at a time. When I'm done with that command, I just print to the command line. I'm creating a PDF for this tab, and then because it's a for each loop, it's going to run through each of those tabs, and then when it's done, it'll just say finish creating those. So that's my function called publish PDFs. Now, how do we make this work? Let's say you wanted to do something where every time someone went to save the drawing, you wanted to make sure you updated all those PDFs for all those tabs, and you wanted to be automated. And so I want to show you an example of how we make that work. So I've defined my function called publish PDFs, and in my startup, I'm going to demand load it, which means, I showed you this before, we define a function called publish PDFs, which will load the program file. In this case, I've saved it as a separate Lisp routine, and then it loads it up and then runs it as a demand load function. So I think I've explained that once to you before. So the first thing I'm going to do in my startup is I'm going to do something called undefine the save command. Now this is somewhat dangerous because basically I'm removing or disabling the save command. So if someone goes to type save after this, it will not work because I've undefined it. But what I'm going to do right away is I'm going to redefine the save command as my own save command. So the first thing in this define function, command function, is going to be, we're going to turn the command echo off, set it to 0, and then I'm going to run the the .save command. Now, for those of you that are unaware, you can undefine any command inside of DraftSight, but there are other commands within DraftSight that are what we'll call the core commands. So even though save doesn't exist, .save, the core command, still exists as the original save. So we're going to run that save command first. So we're actually going to go ahead and make sure we do save the drawing. And then I'm going to use my yes/no dialog box to say, do you want to publish all the layouts? And if someone says yes, if the value of yn is set to 1, if they say yes, well, then I've got two choices here. I could either initialize the export PDF dialog box and have that pop up, or I can run my PDF, and simply all I have to do is use a semicolon to determine which one I want. But I could use either one of these functions here in this program, and then this ends the progen and this ends the if. And then when I'm done, I want to turn my commando echoing back on. I'm going to set it back to 1, and then we use that print C like we did in the past to basically remove that little nil statement. So let's talk about how that works. So if I go back to DraftSight and I'm in the drawing, and let's say I'm in model space and I look at this, you notice this is not correct here, but let's just go ahead and say I want to save the drawing. Here it comes up and asks me if I want to publish all the layouts as PDFs, and if I say yes, right now it's going to launch my export PDF dialog box. But if I want to use the other function that we talked about, or my publish PDF function, let's go over to my startup. And where do I have it here? Here's my save program that I just showed you. And I'm going to turn this off for initialize using the export PDF. I'm going to use the publish PDF program that we created. I'm going to save that. And then in this case, I'm just going to reload startup because I'm not going to get out of this drawing. I'll just reload it. So there it is. It's loaded at my startup function. Now, if I go to save, it's going to ask if I want to publish all the PDF layouts. I say yes, and you'll notice that it's walked through and it said creating PDF for sheet 1, detail F, and also ISO view. It actually created all those PDFs. And I'm going to jump over to look at my drawings here. So here are my PDF files. So I think this view, I wanted to show this because in this view, currently something doesn't look right. If I just go quickly to the PDF, here's my PDF that I created, my vpump-3.dwg, and then it called it the ISO PDF. So it created it. Well, as we know, this drawing doesn't look right. So what if I go in here and let's just go ahead and move this, let's fix this view and move it from this endpoint to this endpoint, this arc that didn't look correct. And then if I just go up here and save the drawing, lay out, do all my PDFs, very quickly it has now gone off and created all those PDFs. So now if I go back and double check that ISO view, you'll notice that it's correct. So it just ran through that sequence of events for me. It created a PDF of all the different views, the ISO view, the detail view, and I think also my sheet view. Those were all just done automatically, just by a quick save that triggered, our quick redefine of save command that just triggered that program to happen. So I think it's a really interesting example of what you can do with Lisp in terms of automating some things, and especially in this case, automating the publish of your PDFs for your program. Now, the other thing that you want to keep in mind is sometimes some of the commands inside of DraftSight have two versions. There's the save command, and then there's also, sometimes in the menu, you'll notice there's an underscore save command. And so you may want to define a function. In this case, if I want to make sure that the menu is working properly, if I pick on the menu and it runs the old version of save instead of the current version, it might just be because it's actually running an underscore save. And so here I defined a function called C:_underscore save, which is basically this function. So it's just a little bit redundant, but sometimes you got to watch for those things that the menu may be launching an alias or a different version of the command that you're trying to overwrite. So let's talk about some best practices. Now, most of this I've already covered, and so it's just kind of a brief review of some of the things that I think are important to keep in mind. Again, when you're writing your programs, try to make sure you line up your parentheses so that they're easy to count. Probably one of the biggest issues that you'll find in writing Lisp code is that you're missing a parenthesis somewhere. And so just lining those things up makes it much easier to find those, especially when you're just missing one. Sometimes it could take a while to find that one rogue parenthesis that somehow got away from you. Also, make sure you use that progen function to combine or to put into a container or group those functions, especially when you're using if statements and while loops and repeat loops. You always want to make sure if you have more than one thing happening that you have a progen to combine those variables or those functions together. You don't want to use tabs and strings, and you also want to be careful with your names for your variables. You cannot use a variable t as a variable name. You don't want to set t to something. That will cause all kinds of problems. Actually, I don't think you can do it. It'll probably create an error. But you want to make sure also when you create variable names, I tend to try to, especially if I have a lot of them, I try to keep them all the same length, same number of characters, so that I can space things out a little bit more evenly in my programs. It tends to help if you can keep the names short. You also want to be very careful when you name them. You don't want to use any command or function names for your variable names. That might cause a problem. Now, if we're like we did with the save, we redefine save as a function. That's a case where we did it intentionally, but you wouldn't want to use save as a variable name inside of your programs. It's just you want to make sure you stay away from any commands that you know of for your variable names. Oftentimes, if I'm writing a program for a company and their name is ABC, then a lot of times I'll use ABC and then a definition of a function name that makes some logical sense, so I can know that it's unique and it's just going to work for them. You also want to make sure you try to use lowercase. I can't tell you. I've read a lot of Lisp routines and I've seen some folks using uppercase. Very difficult to make things be consistent. I would just try to stay away from that. It prevents you from holding that shift key down and wearing it out on your keyboard, especially if you're doing a lot of code. You also want to make sure one of the key things is do not write programs and test those programs while you're doing a production drawing or while you're working on projects files. Make sure you test your programs in non-important test files. I can't tell you how many times I got an idea to write something and I started writing it while I was working on a drawing, only to lose a couple hours worth of work because I either crashed the dialogue or I did something wrong, personal, it was my fault, of course, and, creating that file or that issue, you don't want to lose work. So be very careful when you're writing your programs to make sure you're only doing that in files that are test files. Like I said before, you want to make sure you use logical names for your variables. When programs get to be large, sometimes you start running out of names to name things, and so it can be difficult. So be very logical with your names. Also, you got to make sure you can't start variable names with numbers. I think we covered that very early on. Also, when we talk about paths and file names and drawing names, if you're having to do anything that has standards, you want to try to keep layer names, file names, different types of things as short as you can. I've seen a lot of cases where people are creating either layer names that are extremely long or file names or folder structures with very descriptive long descriptions in the name, and that can cause all kinds of problems. There is a limit to sometimes how long layer names can be or how long certain things can be inside of DraftSight. So, and that's the same with all these CAD programs. They all have that same limitation, and so you want to be very careful about that, especially when we start looking at X-referencing and putting references inside of references and combining files. And if we do any kind of automation around that, you can run into all kinds of problems if you have spaces in the names or if you have really long paths and really long names. So just something to keep in mind. I like to do demand loading. I showed you almost all the examples I gave you. I was doing a demand load. I don't like to load up those programs unless I think, unless I need it on every single drawing. So in most cases, I'm going to demand load. And also, you want to be careful. You don't want your startup program to be extremely large and have a lot of things in it. I've actually helped some companies and organizations that were getting very frustrated because it would take 2-3 minutes just to open up a brand new drawing because of all the things that were put into their startup. And so you want to be very careful on how much you put into the startup and how many things that you do load up. And demand loading is one way to keep things from not getting too slow, and also to make things just a little bit more simplistic. I also like to take things like, for instance, we did the yes/no function, and we did the dd get string, and all those. I like to put those in a separate file, maybe call it my functions Lisp, and then load that from the startup. If those are functions that I'm going to be using over and over again, it's just. Or if there's certain variables or things that you want to control, sometimes it's good to put those in a single Lisp routine that maybe isn't your startup, that your startup will launch, but sometimes it's good to separate those things. It really depends on how many things you start adding. I would just try to, as a reminder, just to try to keep things simple. I think it's really important. And so when it comes to references, there are so many different websites that are available, and if you just type Lisp and DWG and any kind of, if you just do a Google search on any of the things that you're trying to do, chances are you're going to find some responses. You're going to find some good websites that are available. Also, I would also encourage you to go up to the platform and the 3D Experience platform. The forums that exist up there are definitely forums for DraftSight, and I do notice that people are putting up questions for Lisp and different kind of functions and programs up there, so that's a really good resource for you to start out with. Also, I would encourage you, if you want to get deeper into Lisp training, there are a number of books out there that are available, and what I would recommend is going, if you can, to preview the book before you purchase it, because there are some books that are written very well and they're very easy to understand, and other books that are written in a different format or a different methodology that might be harder for you to understand. So I often encourage folks that are going through this and trying to learn more about Lisp to go through and look at those reference materials and maybe test them out before they make the purchase, because there are very different approaches to this. Now, you might see that things that I've been doing are very different from some of the other things that you've seen online. The good news here is there's no real wrong way to do it if you get the right result, is what I often say. So that will conclude the training for the introduction to Lisp and DraftSight. I hope you've enjoyed this series. I know that there's probably some questions that you have. I feel like I've left out so much, but there's at least enough, I think, in these training series to get you up and running in terms of just creating simple Lisp routines, being able to do maybe even a little bit of interface design, and to be able to automate a couple things. I look forward to seeing if you guys can add some more automation to your portfolio of things that you're doing, and hopefully speed up your workflow and your process. I hope you enjoyed this series. I had fun doing this, and hopefully I'll see you again soon. Thank you so much for your time.